Okay, let's continue with our, I think I can finish this time with the last example, with an example for neural networks. Then you will be ready for the lab exercise as well as the long test. Okay, so let me share my screen. So in this last session, we are going to do an example to make things a lot clearer on how artificial neural network backpropagation with a single hidden layer and single output is being computed. Okay, just so to recap that in the case of feed-forward training or training, that means building the model. So we are going to compute the weights. Okay, in the feed-forward, in this case here, where is this? Can I have like a spotlight there? Okay, here in the feed forward, we are using whatever weights that is being assigned or randomly assigned, or at the start are initialized weights. And so we compute the output based on this is the input, and then we compute the output of that particular layer, and then using that output will be the input on the next layer, and then we compute once we get the output of that layer, we compute that as the input of the next layer, and so on until we get the final output. Okay, then don't worry about the weights, we just assign the weights randomly. Okay, then now we have an output. So once we have an output, this is the time that we are going to correct the weights. Okay, so now all the weights are assigned. We know the output, then the output against the target value is compared, and that error will give us the new updated weights. Okay, this is the equation for the hidden layer weights. Okay, for our case, we only have one hidden layer. So for the hidden layer weights, this is how we're going to output, and then this is how we're going to update the weights. And then afterwards, we compute the weights for the input layer. So the weights for the input layer will be updated like this, and then that's it. Okay, so we compute, we recompute, and we recompute until, okay, now the weights are being adjusted. The weight, then after that, the weights is adjusted. Okay, and then we compute again the next layer, the weights is adjusted for that particular layer, and so on. And then we go back, feed forward training, and then forward compute the output with the new updated weights already here. We use the new updated weights, and then now we compute what is the output. Okay, and then we go back propagation. Okay, using these equations to update the weights of the hidden layer and the weights of the input layer, and then we update the weights, then we compute again. Okay, so this is an iterative process until the error that you compute here achieves a certain, acceptable tolerance. Okay, so that means if your error on the output layer against the target value is quite small, that means your model is quite, can accurately classify or can accurately come out with an output according to the observed output from the data. You understand? Okay, I hope that is clear. So now let's go to one example. I want to show this. Do you prefer this, or I'm not? I want to show like this because there are so many information. Okay, anyway, let's just show presentation mode. So yeah, this is the one that I just discussed, and then now let's go to one example. One example is, again, we use example of the XOR because we know that the XOR classification cannot be solved using perceptron or we just know with a single layer perceptron. But then in this case here, we're going to add one layer and see what happens, and see that by adding one layer, it will be able to classify correctly. Okay, so now we have two inputs, X1 and X2. Okay, and then we will have the V's. Maybe we So this is V, okay. If you assign this V1, so that's V10. So this is a V11, okay. And here, this is V12. Okay, remember the output is Z1. So everything, the weights here, the output of Z1 is multiplied, the V1 multiplied by the input. So that V1 multiplied by the input X. So this is your X0. Okay, so now you output Z1. Now, if you output Z2, your input, again, you have an X0 here, multiplied by that. This is V20. Okay, and then here going to V2, so that's V21. Okay, again, this one going to V2, that's V22. Okay, so you multiply the V2 times the input X, you get the Z2. Okay, now you have two outputs, Z2 and Z1. Using those outputs, you also have the gain, the bias, sorry, the bias of Z0. Okay, so now, so it's a problem here. Z. So in that case, that's Z. Z, okay, the Z0, Z1, and Z2 multiplied by, where is your W10? This is W10. Okay, and then Z1, it will be W11. And Z2, this W12. Finish. You can see that. Okay, it's just all about substitution now. So now we can compute. So if we substitute all the weights here and the input, okay, you have input here, you have another input and one output like that. The input X1 and X2 like that, you can update Z1, okay, input like that. So now you can, then you go back propagate, okay, you can now compute the updated delta of the weights by this values. Now you use the value of your Z0 depending on you only have one layer, so 1, 1, 0, 1, 2, and 1, 1, 0, 1, 1, and 1, 2. Then the same thing as you update here, and we say that you only have one layer, so your K is equal to one hidden layer, so your K one output, yeah, and so your K is only one. So all of these, there's no summation, and then we can just all substitute. So let's go. So now clear everything. So these are the assignments of your weights. Okay, so this is 1 all the time. That's X0. That's 1 all the time. And this is also X0. That is 1 all the time. Okay, so you have V11 and V12. Okay, this is correct now. And then V21 and V22. Okay, and now this is your V2. Okay, now here you have, this is ZZ. This is your Z0 multiplied by W10, and this is your Z. This is your Z1. Okay, output of that, and this is your Z2. Okay, there you go. So now, I thought this is initialized already, so it's not initialized. So okay, so initialize some weights. Okay, it's the same. It's a repetition. So now this is good. So this is the one that has values now. So first of all, we compute the output of Z1. So Z1, what is the value of your Z1N? ZN1. So initialize our V. Where did we put the? Okay, initialize it to 0.3, 0.20. Who did this? Okay, initialize randomly and those values. Here we initialize them. Okay, randomly initialize the values. So that means that in this case here, this is your Z1. This is your V1 value, V10 value, V11 V1 value and V12 value. Those are the initialized values of your weights. Those are the initial values of your weights. We didn't put it properly there. And so now your input is 1. Okay. We start with the XOR. Yeah. The XOR is you have X1. Okay. Let me, for easy, I think it's easier to just picture it and then we'll open it. Okay. Okay. Now I don't need to do this. I clear all and then we go here. Okay, this is initialized already and we compute here. Then I open the table so we can discuss them properly. Okay, here. So that is the table that we are going to consider. Okay, now, so as I said, this is just purely substitution now. So feed forward, we're going to compute your Z1 and Z2 and Y1. Okay, so now we are saying that in this case, Z1. Okay, so if you compute Z1, you compute this minus ZN1, which is actually this one, a V1 transpose times the X. So our V's are initialized this one. V, okay, V10, V11, and V12. So V10 multiplied by 1. Okay, so this is equal to V10 times X0 plus V11 times X1 plus V12 times X2. Okay, so now that's that one. So what is X0? X0 is always 1, so that's correct. V10, that's the initialization. The substitute V21, substitute, and then substitute. What is your X1, X2? We are taking the first row. Okay, so X1, X2, 0, that's fine. So that's the result, -3. So now your Z1 output, you substitute this one into Zn, and so your Z1 output is this one, 0.43. Okay, and you do the same thing for Z2. So Z2, you're going to the same thing. This is equal to V20 X0 plus V21 X1 plus V22 X2. Okay, yes. Yeah, Caloso. Can you wait 30 minutes? Okay, hold on. Where is my, I have to mute myself. Okay, wait. Caloso. Okay. Yeah. Okay. Yes. Sorry. So now you have this one. So now the V20 initialized to 0.25. So that's that one. V21 initialized to -0.4 and V22 initialized to that one. And now we know your X0 is always 1 because that's the bias. And we take the first row, 0, 0, that one. Okay, now the value, we substitute this, and the value of Z2 is 0.56. Okay, we record that. Now, to compute for Y in, so Y in 1. So Y in 1, again, we are going to do this one. Okay, that means that you have Z0, okay, times what's the weight here? W. Okay, let's start with W first. Okay, weight first, yeah. W10 times Z0 plus W11 times Z1 plus W12 times Z2. Okay, So Z2 and Z1 are computed here. So that's 0.43 there. It's finished. And then this one also is 0.56. That's finished. And so this is the weight, initialized weights. This is initialized weights. Initialized weights multiplied by this is Z0. That's the bias. Okay. Now your output is 0.42. It is not 0. The output is supposed to be 0, but your computed output here is 0.42. Okay. Any questions on the feed forward?
Yes.
Yes.
I have a question.
Hmm.
So I see that there's Z in 1 and there's Z1, and then Z in 1 is 0.3 negative, and then Z1 is 0.43.
Hmm.
I don't
Yeah.
understand where we get the Z1 equals to 0.43.
Yeah, it's here. It's here. Watson. Look at this one. Down here below. Well, it's just a simplification. Yeah, it's here. Down here below. This is the output. So what we did was compute first this part, the exponent part.
Okay.
Okay. So that it's easier to trace. So we compute first the exponent, then plug it into this equation. And so that's why we come out with the Z1 and Z2 output. Okay.
Okay.
Anything
Yes,
else?
sir.
No problem. Anything
No.
else? So you can ask, sir, what about if we use this data? It's fine. You can also do that. But now your output will be 1. It should be compared with respect to the 1 output. In this one, it's compared with respect to the 0 output. Okay? That's it. It doesn't matter because we're taking the data. So whenever you correct this, you have to go through, run for all the data in order to make sure that your model is correct. Okay? Okay. I hope that is clear. So no problem with the feed forward. Now let's go to the backward. Okay? Okay. Now, so the weights we have, so the updated way, the random values, these are the output, and then that's that one. I think I just write it the way it was there. That's fine. Okay. Now we have to do the output. Oh, it's called an output layer. Anyway, I call it the hidden layer and the input layer. So in this case here, you call it the output layer and the hidden layer. That's fine. So now, if we compute this, the output layer, okay, so we have our target value and the output value, and then multiplied by the delta K. So this delta K multiplied by the Z. Okay, anyway, so let's concentrate on this one. Let's not do this first. So we are saying that summation remove because there's only one output. That's fine. So let's go directly. So now here. So remember that we have to compute the delta first. Okay, maybe I should also, I think it's easier to make pictures so that it's, and then make another picture. And then make another picture. Okay, we are recording, right? Okay, yes, we are recording. Okay, now let's go, let's compute this one. So let's start with this one, how we are going to compute the delta. So we compute with respect to an output. Where's the delta? Here, so here. So there is the yk, in this case, our k is 1. Okay, don't forget that, our k is 1 because we only have one output. K is 1, so y output was 0, okay, was 0.42. So 0 minus 0.42, okay, that part is this part multiplied by the output 0.42, that's it, multiplied by the target. The target is 1, okay, is it 1? Where is this one? The target, we are using 0, 0. The target should be 0. Okay. We are using this. Remember, we are using the input. There's something wrong here. Professor was sleepy. Okay, so remember, we are using the equation, this one, a 0, 0, and output 0. That's why it says here that the output 0.42 and not 0. We're expecting a 0 output because we are using x0, x1 0, x2 0. So all the x's are 0. So if that is the case, it should be the first case, because there's no other case where you have an output of x1, both x1 and x2 are 0. So this is, and this is, yeah, this is correct because this is B1. Okay, anyway, so maybe he was confused. Maybe he took this, to have an output of 1, it should be one of them should be 1, but that is not the case. Anyway, so the output should be 1. I mean, the output here should be 0. Okay, that is our case because that is how we took the first row in the data. Okay, the output should be 0. Okay, let me correct this. Okay, and don't mind. Okay, let's just say that, yeah, this was correct because we need to trace the number. So 0.102 is okay. We'll just use that no matter if it is wrong. And then we're going to compute now. After that, computing the delta K, we compute the, I cannot use the mouse. Okay, so now is using the delta 1 multiplied by the W. So delta 1 multiplied by the W as your delta in. Okay, let me, this one I don't understand. You're using the W11 multiplied by the, let's go back to the equations. Yes, this one okay, we're supposed to do this delta 1. Okay, so now we have, from here we have the delta 1, and so you delta 1 multiplied by W11. Let me just go back to the equation so that we can. Where is delta multiplied by W1? We should output first. He's computing this already. Okay, we should update first the, he's computing that. We should update first the W. Okay, is the one that confuses me. We should not do this one yet. We should update the W first. So how do we correct your W? Okay, I think we should use this part here, which I don't see him using.